quite a bit of examples, and I'm going to have a couple of them for you guys to work on your own, but I think we have 3 things to add to our sheets today. So let's go from there. Well, when we start these things out, obviously you had your given. And what's nice with the ones that are fill in the blank, it's a matter of you guys trying to figure out what's their mindset. Why did they do what they did? And sometimes that's difficult for students to do because you want to kind of do things on your own. Because you guys are independent, but you don't want to be independent thinkers sometimes and do things on your own. So catch-22 is weird. Weird. Anyway, so obviously your first steps are your given. Those aren't too terrible. So if that's given, if A is parallel to B, then we went to our diagram. We mark it. Okay? Now after that, it said that angles 9 and 11 add together to equal 180. Well, in the diagram, these two guys form what? A linear pair. They're supplementary. I told you guys yesterday, let's use this as definition of linear pair because it's right out of a diagram, okay? So now you had that. We knew that those two guys were add up to equal 180. But then look at what their next statement was. It said that 11 equals 14. Well, if 11 equals 14, what angle pair relationship occurred?
Alternate interior.
Alternate interior, very good. So the reason that you would throw in there would have been, you have to use your symbol, unless you want to write it out. If 2 parallel lines are cut by a transversal, alternate interior angles are equal. Now, the reason I'm going to say that they're equal instead of congruent is because the step prior to it talked about things in equality. Remember, they're interchangeable. You can say equal or congruent depending upon what you're trying to show. A lot of times we do congruent because it just says prove something incongruent, but sometimes you'll switch it to equality because they're using it in terms of addition. Remember the rule, you can't add over congruency? That's just a little thing like that. How's that interior? Because 11 and 14, they are inside the lines on the opposite side. Okay. Inside opposite sides. Okay. Yes, ma'am. Yeah. I might have been speaking about a different problem. You guys heard that. Because it should have been, I would have said that 9 plus 11 is 180 there. I apologize if you heard it wrong. I'm sorry. Because they're not consecutive interior, because one's on the outside, one's on the inside. You look at the picture. Okay. Oh well, I'm sorry. And then lastly, why do we say that 9 and 14 add to 180? It's substitution. I know you want to say transitive because you see the diagonal here. Transitive will never happen if there's addition in between. Okay, transitive will never happen if there's an addition symbol in there at all. Transitive is always just going to be that A equals B, B equals C. It has to be that specific. So this is just a substitution set, you're done. Okay? I think in 4 there's something I have to show you guys. It's one of the ones that's new. There's a new step that's shown in there that we didn't get a chance to get to last time. I think 4 is the easy one. Oh, excuse me. 5 you have to use a separate step. What's that? I'll get over it. So the third one. actually needs something that we don't know about yet. One thing I want you guys to see is that you have to show that two lines are parallel. Well, we know how to prove angles are congruent if lines are parallel, but we don't know how to say that lines are parallel if angles are congruent. So what I want to do real quick before we finish this one out is I want to put this together. I want to put this one together. Now, yesterday we wrote out a whole bunch of different ways of if two parallel lines are cut by a transversal, then alternate interior angles are congruent, or consecutive interior or supplementary, or corresponding angles are congruent, or alternate exterior congruent. We knew all four of those. Well, if you work backwards from it, you can say that the lines are parallel then. That's what this last little bit that we look at today is going to allow us to do. That's technically showing that lines are parallel. Well, how do you show that lines are parallel? Well, you do one of these four things. If alternate interior angles are congruent, or alternate exterior angles are congruent, or corresponding angles, or consecutive interior or supplementary, then the lines are parallel. Okay. It's working backwards from what we did yesterday. Just like when we said before, if you have a right angle, it measures 90 degrees. If an angle measures 90 degrees, it's a right angle. It's the same thing going forward and backwards via the definition. It's called a biconditional statement. It's the same thing. It's just all four of them put together as one. That's all. So if you ever have to prove that lines are going to be parallel, all you have to be able to do is show that one of those four things happen. That's it. It's just a matter of labeling out what it looks like. And you guys will see in the proof on number 3, you probably weren't sure of the very last step of what's right, but the rest of it, getting to it, is pretty easy because there's some substitutions and stuff like that. It's just, why can you say that the lines are parallel? Well, this is how it's going to work. Okay. Can I go back to it real quick? Yes, no, maybe so?
Yeah.
Yeah, wait. Okay, I'll hurry up and wait. It's all right. All right. So going back to it, we had lines were parallel, and one is congruent to 2. So G and H are parallel to one another, and one is congruent to 2. So after that, looking at our two parallel lines from the transversal, why is one congruent to 3? What's the angle pair then? You're right. What's the angle pair? No. Is it alternate interior, exterior, corresponding, or consecutive interior? Perfect. They're corresponding. So I can say that 1 and 3 are congruent to each other because if two parallel lines are cut by a transversal, ugly symbol, corresponding angles. Okay, perfect. Gotta have the symbol. Have to have the symbol. And now, 1 is congruent to 2, 1 is congruent to 3. Why is 2 congruent to 3?
Oh my God, I got that right.
Because of what? Ah, careful. 1 is 2, substitution. 1 is 2, 1 is 3, 2 is 3. It's substitution. And now you're right. You're saying that 2 and 3 are now corresponding angles. And since corresponding angles are congruent, the lines are parallel. So corresponding angles are congruent. Lines are parallel. That's what it would look like to show that lines are parallel. And you're going to have a couple more of those later on this afternoon. All you have to be able to do is show that one of the angle pairs that occur, exterior, alternate interior, corresponding or consecutive interior, are supplementary. If you show one of those four, then you can say that the lines themselves are parallel. Okay? It's the converse of what we did yesterday. It's just working backwards. That's all. It's very exciting. Okay? I'm almost done with the test itself, so you guys know. It's a mixture of the algebra from these types of problems with corresponding alternate interior, things like that. And it'll have a couple of fill in the blanks and a couple on your own proofs. It's nothing that you haven't seen. It's not like literally the exact same things, but I mean it's the same complexity. There's nothing that should freak you out because we've been working our butts off on this stuff for the past month or so. So everything's really straightforward. Again, just start out with what you know. You're given that you've got your parallel lines, so you fill in the blanks. G is parallel to H. Here's your given. I'm going to draw my little arrows. Yes, ma'am? What's that? Yeah. So I fill in the blanks real quick on the two that are parallel so that way you can see which ones are which. What? What's that? Oh, I used to write in two separate sets. Okay, that's a good question. She was asking why I didn't write 1 is congruent to 5 on the same line. Normally I usually write out all my given steps separately because remember when you have given steps, let's say you had midpoint. If you had a midpoint, you'd say something about it right away before you went to your next given. Yeah, I try to keep in that exact same mindset so I don't skip over something. So, I mean, right away, I could probably do something, but I don't know what yet until I get to the next given. Because the next given tells me that 1 and 5 are congruent. So then I go to my diagram and I mark it. It wants me to say something about 5 and 3. So I got to figure out a way to say that 5 and 3 are the same. Well, what else is the same as 3 in the diagram? 1. What's the reason? Corresponding angles, but how do you write the reason behind that? Better yet, how do you write that? The what? The funny sign thing. Yes, the funny sign thing. You have to put this in. If 2 parallel lines are cut by a transversal, I mean, if you want to write out if 2 parallel lines are cut by a transversal, if you want to write out 9 words, go for it. Or just go, funny sign. What's that? Okay. Bless you. So 1 is congruent to 5, 1 is congruent to 3. What do you say? Very good. See how fast these are? These are super fast when you start going through these. Okay? I cannot stress the importance of marking your diagrams, figuring out what patterns you're falling through, and go from there. Okay? Yes, ma'am.
Can you come here real fast? I just
Can't walk that fast.
I just have a question.
Yes, ma'am.
Okay, so like I erased it already. I had like the exact same stuff, but I had these two switched, the given and this.
That's okay.
I did this one first, so that
That's
wasn't
fine.
wrong.
No,
Okay.
not at all. What Sheila had there, guys, is that she knew that we had to get something between the 5 and the 3. She put this here before talking about the next given. Is that okay? Absolutely. Absolutely. Guys, there are so many different ways to do so many of these proofs. I had other people talking about extra information. They just put more stuff in there. Did they need to have it in there? No. Is it wrong that it's there? No. So it's just a matter of trust what you have. Don't just go, oh no, he didn't do that, and erase it all. Trust what you have and then see if it makes sense. Because that's perfectly fine.
Okay, yeah, because I still got the ones on top of
Yeah, no, that's fine. I mean, even if you wrote it down, let's say you wrote down, 3 is congruent to 1. You know, then you could have had, it depends on how you wrote it, you might have written out in a transitive step. But it's, as long as your logic is correct in the way that the sequence goes, it's fine. These two are interchangeable. It's okay.
Okay.
You can't say that the right angles are congruent without saying that the right angles first, though.
Yeah.
I'm sorry, what was that? Oh, but they had a question. We have to, because there's a definition here we haven't talked about.
Why don't you check them to make sure they're done before you explain them all?
Now this one I was confused on. I don't know.
Well, what happens here, what happens with this one, is that there's a shortcut to show how this works. And it deals with a definition that we spoke about, but we haven't used yet in a proof, because we've never had a proof that ever used it. So if we go back and think about the following definition. If this is 160 degrees, and this is 160 degrees, and this is 20 degrees, are both of these angles supplementary to the same angle? What's supplementary again?
That's a 180.
180. Are those two angles supplementary to 20? What's 160 and 20?
Oh, yeah.
All right. So since the two angles are these two are supplementary to the same angle, they have to be congruent. It's called congruent supplements. Remember, it worked the same with complementary. If two angles are complementary to the same angle, they're congruent. This is a shortcut way to do this proof by using this definition. So, might as well define it. Congruent supplementary angles or congruent complementary angles. That's what we're going to look at. Since they both basically do the exact same thing. One of them just adds to 180, the other is to 90. We can fit them both in the same box. Because the way we write it out is going to be the same. Guys, can we please stop talking? Thank you. So what I do here is, it's not so much like a progression or a proof or anything out of it. I just want you guys to have this definition because it's a nice shortcut to use for some of these. Otherwise, you'd have to say the supplementary angles and add to 180, find some other setup that equals 180, do some substitutions and subtractions, and it gets to be really, really long, big pain in the butt. Why not make it easier on ourselves and use this? So, congruent, all right, if two angles are supplementary or complementary to the same angle, then two angles are congruent to each other. So two angles are supplementary, or two angles are complementary to the same angle. Then those two angles are going to be congruent to each other. And just think about it, two angles that both measure 160 degrees are both supplementary to something that's 20 degrees. Therefore, they have to be congruent to each other. And two angles measured 70 degrees, and those both angles from supplementary or complementary to a 20-degree angle, 70 degrees and 7 degrees have to be equal to each other. So what will happen here is that it might not be a given that you've got congruent supplements, but it's a nice trick to use if you can show that angles are supplementary to each other. So it's not a given portion, but sometimes you'll be able to use this as the definition of congruent supplements or the definition of congruent complements. And this example of the proof that we have here is going to be an example of how to use congruent supplements. You see that better if I move it up a bit? It's always fun when people start looking around like, I can't see. If we had stadium seating, that'd be pretty cool. No, you just be up high. Okay. Yes, ma'am. So let's go back to the proof then, and show you how this is going to work. It's actually really easy. When you start with your given, obviously you've got your given of your parallel. Write it. Once you write out your parallel, then you go with your next part. Mark your diagram and see what happens. You've got G is parallel to H. And then you know that angle 6 and angle 3 are supplementary. Guys, I've had it. I'm going to split the four of you up, and I haven't had to move anybody yet to school year. Okay? I know those two are supplementary because it says so. I know these two lines are parallel because it says so. I really can't mark the 6 and 3 congruent or anything like that because they're not. We don't know if they're congruent. All I know is that they're supplementary. So I just have to look and see, with those two lines G and H being parallel, are there other angles that are on the transversal of the 1, 2, 3, 4 variety that I can say that are also supplementary? 5 and 4 is not on the same line as 1, 2, 3, and 4. 2 and 3. Why are 2 and 3 supplementary? Because they're consecutive interior. Given. So if two parallel lines are cut by a transversal, consecutive interior angles are supplementary. Why? Because it says so on our progression sheet. It says so in our notes. All we had to do was figure out in the diagram where that occurred. So here's your statement then. 6 and 3 are supplementary. 2 and 3 are supplementary. Do we have two angles that are supplementary to the same angle? 6 and 2. So what do you know about 6 and 2? They're congruent. Therefore, angle 6 is congruent to angle 2. And really the only reason is, nope, definition of congruent supplementaries. That whole progression we just wrote out, that's what you use. That's it. You're using the definition of congruent supplements. It's a very, very, very straightforward way to do that. I want you guys to take a minute and try 6. Try 6 and 7 for me. Try 6 and 7. We've got enough information. We got enough examples. We got enough stuff lying around. Overthinking it. So CD. Parallel to AB, which means you have this. Okay? And angle 1, or excuse me, angle 2, is compared to angle 1. Well, 2 and 3 have no relationship to each other at all, as of right now, because they're on the same, 2's not even on the transversal that's going between lines CD and AB. But if you look at segment AB, that is a transversal. Yes, ma'am. Guys, you guys got to start going to the bathroom at some other point in time. I can't have 15 of you guys walking out of here every day. So if you have a transversal right there, what's the relationship of 1 and 3? Opposite interior. Here's your given. 1 and 3 are congruent. 2 parallel lines cut by a transversal. Alternate interior angles congruent. 2 is congruent to 1. 1 is congruent to 3. Why is 2 congruent to 3? Nope. Look at your square about transitive versus substitution. Which is it?
Transitive, I confused them.
It's transitive. Look at your square, guys. What's there for? This is the case of transitive because it's on the diagonal. There's nothing else there. And you're done. Yes, ma'am. If you switch the 1 into 3, then you use substitution.
Okay, but when you get that wrong because you just switched the numbers, not knowing.
No, it's not wrong if you switched it. Because if you said 3 and 1 are congruent to each other because of alternate interior angles, that's correct. It just so happens this is the way that I wrote it. If you wrote it out where you went 2 is congruent to 1, then you had angle 3 is congruent to angle 1 because of you got the same reason here, right? That's fine. And then if that's the case, 2 is congruent to 1, 3 is congruent to 1, then this would have been true because of substitution. This case is set up as transitive. Your case would have been substitution. If you wrote it, you're fine. That's okay. Because like I said, there's more than one way to get to the answer. As long as your logic and stuff going through it is correct, you're fine. And that's what's a little weird sometimes with these. People don't trust themselves. You were fine. Did you have the symbol? Did you have that symbol in there? This one. Then that's great. Perfect. Okay. Look at the next one. I went to go do this one earlier today, and I made it way too difficult on myself. I wound up setting this one up to about 9 steps. You can actually do it in less than 5. What's that? So, it just depends on how you see it. L is parallel to N. And you just mark it. They want you to show that angles 2 plus angle 7 is 180. Which means we should probably figure out some other 2 angles that add up to equal 180. Which ones? 8 and 4? 8 and 1? 8 and 1 well, we don't know that because there's no angle pair relation about 8 and 1. Which one? 8 and 7, yes, but now you're going the other direction. Why not? Yeah, why not do 7 and 6? If I do 7 and 6, watch what happens. I can say that angle 7 plus angle 6 is 180 because they form a line, because of the definition of linear pair. Okay? Yes, ma'am.
So you don't have to go in there and try to find those 4 things that you gave us? Like,
This next step I will.
I know, but like right away you don't have to.
You don't have to.
Okay.
Sometimes, if you do, you can still get there. It just takes longer.
Okay.
Sometimes if you start thinking about it if you start looking like, okay, I mean, if you pick a spot, if you say, hey, I know these are going to go like this, I know that's going to happen, okay? Which means I know that 7 and 3 have to be equal to each other. I know that 6 and 2 have to be equal to each other. Things like that. So here, what I would do right away, since I have 7, 6 written out, why not say that angle 6 is equal to angle 2? Because what's the angle pair relationship between 6 and 2? Corresponding angles. And then I can do a substitution and I'm done. Weird. I wasn't even trying to spin it, I dropped it. So now everywhere I see a 6, I can put a 2. There are so many different ways of going about doing this. You could have done 3 and 6 are consecutive interior angles. You could have then said that 3 and 6 are supplementary. And then you could have said that 7 and 6 are supplementary, which means 7 and 3 have to be the same. And then you could have said that 2 and 3 were supplementary, so 2 and 6 had to be the same, and go through all these double substitutions. You would get there, but that was a lot quicker. What I'd like you guys to do for tonight are the last 4. Tomorrow we'll talk about those. I'm going to talk a little bit more about the algebra stuff that we have yet to talk about. And I'm not too worried about it because it's really easy. It's what's the value of x that makes the lines parallel, things like that. So it's really, really easy. It's a matter of knowing if you have to make them equal to each other or they have to be supplementary. Okay? So finish those last 4 for this evening. We'll do that as well as some other review stuff tomorrow, and we'll test out all this stuff on Friday. Like I said, the test stuff is basically, I think it's 4 proofs, like a couple on your own, a couple fill in the blank, and some algebra. So it's really straightforward. Nothing too crazy. Two things equal the same thing, just put it in for each other. That's it.